Right, so we're going to finish talking about complex numbers. Last two things we got to look at is multiplying and dividing complex numbers. So we ended yesterday by saying I equals the square root of -1. Okay, I is a letter, but in math it stands for a number. What number? That number. Okay. So the next thing we talked about was I squared. Okay, I squared comes up all the time when you multiply and divide. Does anybody remember from yesterday what I squared is? What'd you say, Jack? 1? -1. Yeah, I squared is -1. Okay, so what that means is anytime you have a problem like this, you should never leave I squared in the final answer. This really means 3 times -1, and you should do that out. Okay, so if you're ever doing something out and you see an I squared, change that to a -1, always. Okay, so any questions on why I squared is -1? Because that can be explained. That we did yesterday. But why I equals the square root of -1, I can't explain that to you. That's the same thing as saying why do parallel lines don't cross? They just don't. It's just the definition. That's the way it is. Okay, so same thing here. I equals the square root of -1. It's just what it is. All right, so when you multiply complex numbers together, it's kind of like doing like a double distributive property. Okay, you might have learned it as FOIL. I don't know if your teacher used that for algebra, but it basically means you multiply the first terms, the outer terms, then the inner terms, and then the last terms. And notice what's going to happen when you multiply the last terms. This one has an I, the other one has an I. So when you multiply two I's together, that's where an I squared is going to pop up. Okay, so again, use FOIL, okay, if that's what you call it, or really it's the distributive property twice. That's what you're doing. And as far as multiplying, that's pretty much it. That's all I really need to tell you. We'll just go to an example. But any questions on what I mean to multiply out where those lines are? You do A times C, A times DI, you do all that out. But the difference is A, B, C, and D will all be numbers. Okay. All right, so let's try to multiply those out. So Michael, if I follow that pattern I mentioned up above, start with the first terms, what do you get when you multiply the first two terms together?
We would get 2 times 1 is 2.
Yep, that's good. You can stop there. Yep, so 2 times 1 is 2. That's your first terms. Okay, now we'll do the outer terms. Okay, so we're going to multiply the 2 and the -I. So Kristen, what would 2 times -I be?
-2i.
Yep, -2i. Marcos, the inner terms, what's 1 times I? Just I. And now the last term. First of all, I want to look at it in 2 steps. It's a positive times a negative. So Gabe, what's a positive times a negative? Negative. And it's I times I. What's I times I? Do you know? I squared. Okay, that's fine for now, but there's a couple things here we need to simplify and then combine like terms. Do I have any like terms there I can combine right now? Yeah, the -2i and the positive I. If you want to think of it as a positive 1i, you can do that too. So Gladys, what would that give me if I did -2i plus 1i?
Oh, negative I.
-I, right? -2 plus 1 is -1i, which I usually just put -I. And now this part at the end, it's minus I squared. But what did we say earlier I squared is? -1. So I'm going to change I squared to -1. Okay. And how about Kelsey? What's going to happen here now when I subtract -1? Yeah, it's going to become a +1. And now I need to combine +2 with +1 to get +3. So anytime you multiply, or also when you divide, you should always have your real number first, and then your number with I second. And that's it. That's how you multiply two complex numbers. Any questions on that? Okay, multiplication, it's pretty important because when we do division, the way you do division is to use multiplication. All right, so if multiplication doesn't make sense, then division won't either. Yeah, let's try, take a second and try that one on your own. Okay, see if you can multiply those two together.
What was the answer on the last slide?
The last one, I think it was 3 minus I. 3 minus I. Good? Good. All right, so try to multiply those two together. 8 plus I times 3 plus I. All right, Devin, when you did this one, what did you get?
I started with 24.
Yep.
Plus 8i plus 3i plus I squared.
Perfect. So you get 24 plus 8i plus 3i plus I squared. So that's your first step. Okay, now two things we have to do. One, combine the like terms. The second thing, change I squared to -1. So Mercedes, when I combine my like terms, how many i's will that give me?
11.
Yep. So plus 11i. And I squared, we're going to change that to -1. Okay, this time it wasn't minus I squared, so I don't have that minus thing. Okay, it's just -1. Okay, and now my last step, when I combine the 24 and -1, that gives me a real part, Riley, of 23. So 23 plus 11i. Yep. Okay, any questions on that one? All right. So the next thing we want to look at is how we divide two complex numbers. But in order to do division, you have to use something called a conjugate. So let's suppose that I have a complex number. Okay? I'm going to call it z. And that complex number has a real and imaginary part. The real part is a, the imaginary part is b. In a problem, the a and the b would be actual numbers. So this symbol, okay, when you put a z and you put a bar on top of it, that's the symbol for a conjugate. Okay, I still haven't told you what a conjugate is, but I'm showing you the symbol for it first. Okay? So if you see a letter with a bar over it, that symbol means conjugate. And all the conjugate is basically changing the sign right there. That's all you do. So to find a conjugate, change the sign of the imaginary part. Okay, I wrote negate. Negate is just a short way to say change the sign of. So change the sign. If it's a positive, make it a negative. If it's a negative, make it a positive. Don't do anything to the real part. Leave that the same. Just change the sign of the imaginary part. Okay, so I've got a table, and I've got some regular complex numbers on the right, on the left, and then on the right, I want to write the conjugates. All right, so if 3 plus 4i was my complex number, what would be the conjugate of 3 plus 4i? Maybe 3 minus 4i. Yep. That's the conjugate. How about if I had negative 8 minus 2i? It would be negative 8 plus 2i. How about 5i?
Negative 5i.
Yep, it would be negative 5i. And if that one's a little tricky, you could always think of it as 0 with the real part. 0 plus 5i, the conjugate is 0 minus 5i, which is really, you don't need to write the 0. And how about 3? 3, it stays the same. Again, if that one's kind of tricky, think of 3 like this. 3 plus no imaginary part. The conjugate is 3 minus no imaginary part. So it's the same thing. So any questions on, if I give you a number, how to find the conjugate of it? All right, so next thing we'll look at is we're going to do another multiply problem. And I want to find this. Z times its conjugate. Okay? And in this problem, here's Z. It's 3 minus 4i. So first thing I need is the conjugate. How about Miles? What's the conjugate of 3 minus 4i? 3 plus 4i. So I'm going to multiply together what I have and what he just said. 3 minus 4i times 3 plus 4i. And just by looking at it, without even doing much, I already know the answer is 25. So we'll see how I did that in my head so fast. I didn't do FOIL in my head, because you don't need to. We'll do it the first time, but then you're going to hopefully see a shortcut. So let's start. What's 3 times 3? That gives me 9. And then 3 times 4i is 12i. And Jamel, how about 3 times negative 4i? Negative 12i. So they're going to cancel. So when you multiply conjugates, there's always something that cancels out, so you can skip doing it. If it's going to cancel out every time, why waste time doing it? So we'll come back to that in a second. And then the last part, negative times a positive is a negative. 16, a little bit more, I squared. Yep. Okay, so positive 12i, negative 12i, that's gone. So the i's disappear from the middle, and what's going to happen to that I squared next to next to the 16? It turns into negative 1. So are there any i's left in this problem? No, and that always happens. That's the reason why we multiply by a conjugate. It causes all the i's to disappear. Okay, so I'm left with 9 minus, and now I'll do this out, 16 times negative 1, just negative 16. And lastly, that turns into a plus. So what's 9 plus 16? 25. So the shortcut, if you want to do it in your head, you basically take the first number, take the 3 and square it. That's a 9. Take the second number. Doesn't matter if you take it with the negative or without. It would cancel. Take the second number, 4, and square it. That's 16. And then just add the 2 numbers that you got. So take the first number and square it. Take the second number and square it. And add them up. That trick only works if you're going to do conjugates. If you wanted to multiply something like this, you still have to do it out the long way. These are not conjugates. Okay, but conjugates, there's a shortcut, and that's what I just showed you. So, if I was going to multiply these together without foiling, what 2 numbers would I be adding together? 25 and 16, which is how much? 41. That's it. That's the whole problem. If you don't remember the shortcut, you can go back and foil it, but you're just going to slow you down a little bit. So 5 squared is 25, 4 squared is 16, 25 and 16 is 41. Okay. So any questions on how to multiply conjugates? Okay, and if you want to see what I just said written out as a formula, that's what you just did. To multiply a number times its conjugate, take the first number and square it, take the second number and square it, and add them up. That's what we just did right above it. All right, so now we know what conjugates are. We know what happens when you multiply conjugates. All the imaginary parts disappear, so now we can do division. Okay, that's the last thing in section A4. Okay, so the conjugate is going to come in handy when we do division. Okay, how do we use the conjugate? Just like this. To divide two complex numbers, you multiply the top and the bottom of your complex number by the conjugate of what's in the bottom. Okay, so to divide two complex numbers, you multiply the top and the bottom by the conjugate of what's in the bottom. And effectively what that's going to do is it's going to get rid of all the i's in the bottom. That's why we do it. It's okay if you leave i's in the top of a division problem, but you can't leave i's in the bottom. And the conjugate will fix that. Okay, the first one I'm going to start you out with is a little simpler. The bottom number is a complex number with a real and imaginary part. The top one isn't. It's just a single number. Okay. The next one we do, there'll be a complex number that has a real and imaginary part in the top and the bottom. Okay. But we'll start out with this one. It just makes the distributive property a little quicker in the top, that's all. Okay, so we have to multiply top and bottom here by the conjugate. How about Wendy? What's the conjugate of 3 plus 4i? 3 minus 4i. So we're going to multiply top and bottom by 3 minus 4i, and you go straight across. Now the bottom we should be able to do pretty quick using the shortcut. What two numbers are you going to add together if you FOIL out everything that's in the bottom? I like the 16. 9, yeah. Square the 3, you get 9. Square the 4, you get 16. Add them up. Now, even though the top isn't a conjugate, it's actually still an easy distributive property to do. It's not a double distributive, it's just single. So just multiply out a 1. And when you multiply a 1 to something, what does it do to it? Nothing. So it stays the same. So we have 3 minus 4i at the top. What do we have in the bottom? 25. Okay. The last step is to write the final answer. And usually when you write the final answer, the real part is separate from the imaginary part. If you leave it like this, it's all combined together. Okay. The way you separate it is you take the real part, put it over 25, minus in this case, because it's a minus. Take the imaginary part and put that over 25. That's how you separate it into two fractions. Just take each number and separately put them over 25. And that's your final answer. Okay, so real part, 3/25, imaginary part, -4/25. Okay, any questions on that? Okay, so the last one, I'll give you a second. Why don't you try it? And see if you can divide 1 plus 4i by 5 minus 12i. Now, just remember, which conjugate are you using? Is it the one in the top or the one in the bottom?
Bottom.
You're using the one in the bottom. Okay, don't worry about the top. Find the conjugate of what's in the bottom. That's what you multiply by. Okay, so we got to figure out what we're going to multiply top and bottom by to get rid of all the i's in the bottom. What's the conjugate that we're going to use here? Heather?
5 plus 12.
Yep, 5 plus 12i. Now, what I like to do, because it's faster, I like to just get the bottom out of the way first, and then I'll worry about the top. So Wendy, when I do the bottom, what two numbers am I going to be adding together?
25 and 134.
Yep. Okay, and in the next step, I'll actually add those, and that'll be my denominator. Now, in the top, there's no shortcut. We just have to FOIL the whole thing out. So Dave, can you tell me how you FOILed it?
The whole thing.
Yep, just go one step at a time.
I got 5
So 1 times 5, yep.
plus 12i
You got a 12i, right?
plus 20i.
Yep, then we get 4i times 5i, which is 20i. And the last term.
Plus 48i squared.
Yep, we got a positive times a positive, which is a positive. 4 times 12 is 48, I squared. 48i squared. Okay, so that's a good start, but a few things we need to do. We have to deal with the I squared, the like terms, and we have to separate it into two fractions. All right, we can start with the like terms. Becky, what's 12i and 20i?
32.
So 32i. And let's deal with that at the same time. What's 48i squared? Yep, it's a negative 48. And also at the same time, I'll add 25 and 144. If you want to do everything I did in separate steps, you can. It's just going to be a lot more writing. So Kylie, what's 25 and 144?
169.
169. All right, so let's combine any other like terms we've got. 5 minus 48. How much is that? 5 minus, yep, 5.
Negative 43.
So you get negative 43, and that's going to be over 169, plus 32, and that's over 169. And that's your final answer. Hey, any questions on that one?
Why is it plus?
Why is it plus? Because
Oh, okay, okay.
that was a plus. If it was a minus 32, you would have had a minus right there. Okay. Any other questions on that one? Okay, so just be careful when you're adding and subtracting. People tend to mix this up with addition. So I'll write a problem like this on the test. And they start foiling it. Okay? If there's a plus sign between them, you shouldn't be foiling. Right? You should just be combining like terms. 2 plus 1 is 3. 5 plus 3 is 8. Those are the simple ones. The only time you foil is when you're multiplying. And you use multiplication when you divide, and obviously when you just do regular multiplication. All right, so that's the end of A4. So the last section we'll look at for the week is 5.3. We're not going to finish 5.3 today, so we'll do a little bit of it today and finish tomorrow. All right, so first thing they do in section 5.3 is graphing. And it's the kind of graphing that you're used to. It's kind of like an x and a y-axis, but instead of calling it an x-axis, I'm going to call the horizontal axis the real axis. And instead of calling it a y-axis, I'm going to call the y the imaginary axis. And if I do that, what this is the complex plane. And the complex plane allows you to graph complex numbers. You just have to remember the real axis is horizontal. The imaginary axis is vertical. All right, so let's take a look at how we graph a complex number. Jocelyn, looking at 2 plus 3i, what's the real part of this number?
2.
The 2. And it's a positive. So what that means is I'm going to start at the origin. I'm going to go 2 units to the right. And then how about Jamel? What's the imaginary part? 3, positive or negative? Positive. So I'm going to go 3 units up. Right, 2, up 3. So graphing the point 2 plus 3i, it's basically, it's just like graphing the point 2 comma 3. It's the same idea. Any questions on how I graph that point? The mistake I usually see on the test, people switch the real and imaginary axis. They forget which one is which. So just remember, real is horizontal, imaginary is vertical. All right, let's try that one. Marcos, if I wanted to graph 4 minus 8i, can you tell me, starting at the origin, which way do I go?
On the x, you go 4.
Yep, which way?
Right.
Yep, right 4
And then down 8.
and down 8. And just off the screen. Right there. So that's 4 minus 8i. All right, let's try this one, negative 8. James, where would negative 8 be?
Negative 8, that'd be far left. Right?
To the left. Yep, left how many?
8.
8. So we go left 8. And then what's the imaginary part?
0.
0. So you don't move up and down. It's just negative 8. If you don't have a real or an imaginary part, you're going to be on the axis. Okay, and last one, 5i. Okay, how would I graph 5i? Gabe?
Just go up 5.
Just go up 5. How come you don't go left or right? There's no real. Okay. So any question on graphing? Okay. So there'll be 2 questions on the test. All you have to do is graph the points. Just don't mix up the real and imaginary axis. In fact, I think the axes are labeled for you on the test, which one is which. But still, don't mix them up. All right, so the last thing we're going to do, and this is what's going to continue over into tomorrow, is kind of combining what we learned on Monday about polar with what we've been learning the past couple days with complex numbers. Okay, so we're going to take those 2 ideas and combine them together. All right, so suppose we have a complex number. Okay, I'm calling it z. And a lot of times in the notes I used a for the real part and b for the imaginary part. Since we're starting to talk a little bit more about graphing, you can still use a and b if you want, but I think x and y make more sense because you remember x is horizontal, y is vertical. Okay, but it's the same thing I've been doing, except I used to use a and b. Also, we usually put the I after the letter. The only reason I put the I before it is because the formula I'm about to show you, that's how your book does it.
Does it actually matter?
It doesn't really matter. I'm just trying to match what the book does, so if you look it up, you see the same thing. But no, it doesn't really matter if you put the I before or after the Y, and it doesn't matter if you use X or Y. You can go back to A and B if you want. That form, and all the problems on the other page we just did right here, is called rectangular form. The reason it's called rectangular form is because you move left and right, and then up and down. It's kind of like you're moving on 2 sides of a rectangle. Things like that. Okay. So what we're going to look at is writing a number like this in polar. Now, from what we've done so far, you might be like, well, why would we bother writing it in polar? We can do everything we need to do without writing it in polar. We can add, subtract, we can multiply, and we can divide. Well, if you write these numbers in polar, I can get rid of all these steps. I don't have to do any of them. I don't have to find the conjugate. I don't have to FOIL the top and the bottom. I won't have to combine like terms. You won't have to change I squared to -1. And then you won't have to separate it into 2 fractions. I can take every step we just did and make it go away. And you can do the whole thing in your head. But in order to do that, you have to understand how to write a complex number in polar instead of the way we've been doing it, which is rectangular. So let's look at how we could write a complex number in polar. On Monday, we had two formulas to convert x into polar and y into polar. First, does anybody remember the two letters you use in polar? It's not x and y. It's R and theta. So does anybody remember the formula that has those letters in it? It was x equals, and then there was a formula that had a trig function in it too. Yep. Yep, x was r cosine theta. And does anybody remember what y was? Mercedes?
R sine theta.
R sine theta. So all we have to do to convert from rectangular form into polar is change this to that and change this to that. So just plug in those two formulas that we figured out on Monday into our complex number. So instead of x, I'm going to write r cosine theta. Plus, the I doesn't move. That stays right where it is. But then the y becomes r sine theta. I'm filling what's in that box in for y. Now, if you look at each part of what I just wrote, what's to the left of the plus sign and what's to the right, in front of the trig function, what do they both have in common? What letter? R. So whenever you have the same thing written twice with an addition sign between it, you can factor it out and just write it once. So if you factor out an r from the first term, what would be left if you get rid of that r? Just cosine theta. Plus, and what would be left in the second part if you get rid of that r?
I sine theta.
I sine theta. And that is the polar form of a complex number. You don't need to write it twice. You could just point to it. And that's how you write it. That's a final answer. R cosine theta plus I sine theta. So an example of a final answer might look something like this. 2 cosine 15 degrees plus I sine 15 degrees. You don't do anything with that. You don't multiply the 2. You don't take the cosine of 15. That would be a final answer. So in order to write the final answer, there's two things you need. You have to know r, and you have to know theta. Well, let's see, do I still have it open? Right here. So in order to find r and theta, that's exactly what we did yesterday. This is how you find theta. If you're in quadrants 1 and 4, it's inverse tangent y over x. If you're in 2 and 3, that's the 180 plus inverse tangent. So you don't have to write it again. It's exactly what's already in your notes. So that's how to find theta. Same thing if you're on an axis. It's one of those 4. And how did we find the radius? Yeah, use the same formula again. Okay, so now that we know this format, we don't have to figure this out again. This is the format you use every time. You just have to find the r and find the theta exactly the way you did it on Tuesday. Same thing. Okay, so let's try that one. That'll be it. So we're going to write square root of 3 minus I in polar. Now, if you want, there is a number in front of I, and I didn't write it, but think of it as being invisible. What number is in front of I? Yeah, it's like, or in this case, it's a negative 1. If you want to put that in, you can. So, let's start with our angle. So, anytime you want to find the angle, you have to know what you're in. Quadrant. That's why I just showed you how to graph a complex number, so you can figure out what quadrant you're in. So, if you graph positive, negative, you don't have to know what the square root of 3 is, just know it's a positive and a negative. What quadrant is positive, negative? Quadrant 4. Positive, negative. So, what's the formula to find theta in quadrant 4? Do you know? Do you have to add the 180? No. Inverse tangent of, can you tell me what y is in this case? Yep, it's always your second number. Over square root 3. All right, so let's type that in and see what we get. So we got second inverse tangent, -1 divided by square root 3. Okay, so we get an angle of, excuse me, -30. So there's our angle. And can somebody else set up my equation to find the radius? Got it?
Square root of 3 squared,
Yep.
-1 squared.
Plus -1 squared. Okay, so square root of 3 squared gives me 3 plus 1. So what, in this case, my radius is going to come out nice. Graham, what does the radius come out to? 2. So there's my radius. There's my angle. Just plug those two numbers into our problem. Now, if they wanted you to write it as a positive answer, because just like polar, there's 4 ways to write the answer here. What can you add to an angle to make it positive? But it'll keep it
360.
in the same spot. You could add 360. So what's -30 the same as? 330. For this problem, I'm going to write my answer as a positive. The directions didn't say to do that, but I'm just showing you. They could ask you to do that on the test. So you just add 360 to it. All right, so final answer is r cosine theta plus I sine theta. So r, don't forget a parenthesis, cosine theta plus I sine theta. That's it. You leave it just like that. If you were to do this out, like if you took your calculator and distributed the 2, okay, don't do that, but if you distributed the 2 out and you found the cosine of 330 and the sine of 330, you would be changing this back to exactly what you started with. That's why we don't do it out. We just leave it like that. Okay, any questions? Yeah.
So if the answer comes out negative, like the -30, you just add 360 to it?
If they asked you to make the angle positive. They didn't ask us to here, but I'm just showing it to you in case they did. So technically, if you wrote -30 for the angle here, that would also be correct. There's 4 different ways you can write the, there's a lot of different ways you can write the answers, just like in polar, regular polar. Great. Any other questions on that? So now this is what is super easy to do multiplication and division with. Very, very easy. You don't have any of that other stuff that happened before, but you have to know how to do this first. Okay, so tomorrow we'll pick up with, if I give you a number in polar, just like this, how do you multiply it without doing any of the stuff you had to do before? You can basically do it in your head. Very easy. All right, so the first part on 560, 15 to 27 odd and 28, that's the regular way of multiplying and dividing. Find the conjugates, you got to do all that stuff. Okay, on 333, that's like the last problem we just did. There's a little bit of graphing, and then there's converting to polar. Okay, just like the last problem. Okay, so I will be after school for extra help tomorrow. Okay, if anybody needs to see me, if you're going to skills on Thursday, I've already talked to you about taking the test already, so.